All right, hello everyone. This is the 6.6 notes video over trapezoids and kites. So our objectives are to apply properties of trapezoids and apply properties of kites as well. If we read here the properties of trapezoids, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So only one pair of sides are parallel. The parallel sides we call the bases, as you can see in the example here. The non-parallel sides we call the legs. The base angles are formed by the base and one of the legs. Okay, in trapezoid A, B, C, D, A and B are one pair of base angles. C and D are the other pair. If the legs of a trapezoid are congruent, then it is an isosceles trapezoid. So if the legs are congruent, we call it an isosceles trapezoid. So theorems. These theorems apply to isosceles trapezoids. All right. 6.21. If a trapezoid is isosceles, then each pair of base angles is each pair of base angles. So the base angles come in pairs. So what does that look like in our example here? Well, that means that angle G, and as it's marked, would be congruent to angle H. That is one pair of base angles that would be congruent. The other pair of base angles, yes, angle F would be congruent to angle J. All right. So that's theorem 6.21. Theorem 6.22. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So if excuse me, if one pair of our base angles, so in this example, angle L, so it's in this example, angle L is congruent to angle N, that implies that then we have an isosceles trapezoid, so that the legs KL would be congruent to, and the legs are congruent. So that's theorem 6.22. Theorem 6.23, a trapezoid is isosceles if and only if the diagonals are congruent. If and only if the diagonals are congruent. So use the properties of isosceles trapezoids. So the speaker shown is an isosceles trapezoid. So you see this speaker is a trapezoid. It's isosceles trapezoid. If angle FJH, where is that angle? FJH. So this angle down here, FJH, is 85. FK is 8 inches, so FK would be this part of the diagonal there. It's kind of difficult to see. I'm going to use a color other than black. Let's use FK is 8 inches, and JG is 19 inches. So the entire diagonal here, JG is 19 inches. Right. Find each measure. So FGH, where is FGH? FGH, this angle here. So this is 85 degrees. The other base angle, we can go into it, is 85 degrees. So these two angles are 85. The other pair of base angles would be congruent as well. So angle F up here and angle G would be congruent. So let's just call them both X since that's what we're looking for. So all four of these angles, this is a quadrilateral, so all four of these angles would add to the sum of the interior angles of the quadrilateral is 360. So we can use this equation to solve for X. So that would give us 2X plus what? 170 equals 360. And then we would subtract 170 from each side. And we would get that 2x 190 divide by 2 x 3. So angle FGH would be 95 degrees. Right? And then they want us to find KH, so KH would be what segment? Well, it would be the remainder here of this diagonal. So if the diagonals are congruent, then FH would be congruent. That's one of the diagonals would be congruent to JG, meaning that their measures are equal. So if JG is 19, then FH is also 19 inches. Okay. We've got one segment of FH. We've got the FK is 8. We already marked that. So 19 minus 8 would give me the remaining KH segment. So 11 inches. So KH is 11 inches. All right. So let's continue. Isosceles trapezoids and the coordinate plane. So quadrilateral ABCD has vertices A, B, C, and D at their respective points that are plotted here. Show that ABCD is a trapezoid and determine whether it is an isosceles trapezoid. So a couple of things we can do here. Well, to confirm that it is a trapezoid, so let's see, is this a trapezoid? Okay. Well, what's true about trapezoids? Well, they would have one pair of parallel sides. So just by the visualization here, looking at the graph, we probably want to check to see, well, is AD parallel to BC? That would make this thing a trapezoid if those two sides are parallel. We could check AB and BC, but just visual checklists don't appear to be parallel. I think AD and BC would be our best bet. So if to check to see if segments are parallel, we should check their slopes. Well, what's the slope of AD? The slope of AD is rise over run. Well, B to A, we gotta get rise 1, 2, 3, 4. We rise 4. The left 2. So it'd be a slope of -4 over 2 or -2. And then if we check BC, check the slope of BC, rise 2, to the left 1, so -2. So the slopes are the same, so this is a trapezoid. It's got one pair of parallel sides. It's one close parallel. AD is parallel to BC. So it is a trapezoid. We can just confirm it. Well, we should also check that it only has one pair of parallel sides. Make sure that AB and DC are not parallel. Visually check. Those are not parallel. Okay. So we've done that. Technology. Apologize there. Determine whether it's isosceles. So, well, what would make this thing isosceles? Well, if AB is congruent to DC, this would be isosceles, yes. The legs would be congruent. So, one way to check would just be check the distance of AB and see that it is congruent to DC. See if it is. So, let's do that. ABD. As a reminder, the distance formula, we take the square root of x2 minus x1. Square that, y2 minus y1, square that, sum of those, okay? So, what's the link of AB? AB is -3 minus 2 squared plus y2 4 minus 5 squared. Alright, so to simplify this, -3 minus 2 is 5, -5, -5 squared would be 25, plus 4 minus 5, -1, -1 squared is 1. So AB is the square root of 26. We should check to see, is DC congruent? So we use the distance formula again on DC. I'm going to go ahead and plug in, so difference in x values, -1 minus 3 squared plus difference in y values, 0 minus 3 squared. -1 minus 3, that's -4. -4 squared is 16. Plus 0 minus 3, -3. -3 squared is 9. This is their root of 25. Are these congruent? Okay, these are not congruent, so this is not an isosceles trapezoid. It is a trapezoid though. All right. So let's continue. Learn another theorem here. A midsegment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. So, as we see in this diagram, we have midpoint, midpoint, and we connect those. We call that the midsegment. Right. So, trapezoid midsegment theorem states that the midsegment of a trapezoid is parallel to each base, and its measure. So, let's just do a midsegment. Let's call that M. Is equal to 1/2 the sum of the lengths of the bases. So in this case, AF would be a base plus C, the other base. Take half of that, the midsegment is 1/2 AF plus BC in this case. The midsegment here is BE. I guess we could say BE. All right. So let's use that theorem here. In the figure, LH is a midsegment of trapezoid FGJK. What is the value of X? So we've got to use the midsegment theorem, which states that the midsegment, in this case LH, is 1/2 the sum of the bases. Well, what are the bases? FG plus JK. And so if we substitute in the values here, LH is 15. That's 1/2 of FG. Well, that's where X is, plus JK. To solve this equation, let's multiply by 2 to clear our fraction. So that gives us that 30 is X plus 18.2. Subtract 18.2 from both sides. And we get that X is 11.8. Okay. And that's all we were asked. We just asked to find X, and then what we found. All right. Properties of kites. A kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. So consecutive sides in a kite are congruent. So here PS is congruent to SR, QR congruent to PQ. 2 pairs of consecutive congruent sides. If a quadrilateral is a kite, then its diagonals are perpendicular. So here we've got the diagonal. BD would be perpendicular to the AC. If a quadrilateral is a kite, then exactly 1 pair of opposite angles is congruent. So here it's the angles that are between the non-congruent sides. So here, that's for all kites here. Angle J would be congruent to angle L. K and M, not congruent. Okay. The only angles that are congruent, again, are the ones that are between the non-congruent sides. So that's how we determine what angles are congruent in kites. So if FGHJ is a kite, find angle GFJ. So we are looking for GFJ. Let's call that angle X. All right. Well, angle X is between the non-consecutive, or the non-congruent sides. So the angle opposite that would be congruent. So we'll call that X as well. The sum of the interior angles of a quadrilateral is 360. We've used this. We use that on the kites. Really sloppy 360. So we'll use that again here. So this gives us that 2x plus 260, subtract 200, 2x is 160, or x is 8. All right, and so measure of angle GFJ is 80 degrees. Okay. If WXYZ is a kite, find ZY. So we are looking for this segment ZY. Okay. We need to use that the diagonals are perpendicular. That creates this right triangle that we're now looking at. And we can use we should be able to use the Pythagorean theorem here. So Again, as a reminder, the Pythagorean theorem says leg squared, so one of my legs is 8, plus the other leg of 24 squared is equal to my hypotenuse, so zy, let's just call that x, is equal to x squared, so the hypotenuse squared. So if we solve for x, then we found what zy is using the Pythagorean theorem. So 64 plus 4 squared, I'm not sure off the top of my head, 576 equals x squared. This is 640 equals x squared. We take the square root of 640. We get that x is 25. Let's do one decimal place, 25.3, which is our measure for zy. Call that x. All right, so this is the conclusion of your notes. Your assignment comes from the textbook. You guys can go ahead and begin working on that now. Everybody have a great afternoon, and I'll see you guys on Friday.